Today's lesson is how to write electron configurations. Now, there's a reason why we need to understand electron configurations, because it will tell us about where the electrons are located in the orbitals, but more importantly, it will tell us which ones are the valence electrons. But before we know how to do that, let's look at a couple of rules that we're going to follow while we learn how to write these electron configurations. Rule number 1, electrons are lazy. They will fill the lowest unoccupied energy level first, and then they will move up. So there's an order to the filling of these orbitals, and that is the 1s, 2s, 2p, 3s, 3p, 4s, 3d, etc., etc. This is called the Aufbau rule, and we'll show you why they fill in this particular order in a few minutes. And remember, electrons are negative, so they don't like each other, right? They're going to repel each other. So they will fill unoccupied orbitals in the same sublevel first before doubling up and completely filling an orbital. And I'll show you what that means in a minute. We also call this Hund's rule. And our last rule is electrons in an orbital will have opposite spins. They will be up and down. This is called the Pauli exclusion principle. Now, you don't have to understand why this is, just that it is, and that when we write the configurations, we need to be mindful of this. Now, previously I mentioned that there's a certain order to fill the electrons in with these. And don't forget, back to the Bohr model, we had rings around the nucleus to represent the energy levels of all the electrons. And those energy levels represent the periods in the periodic table. So it's all intertwined. And remember, each energy level has the same number of the energy level as it does sublevels. For example, energy level 1 has only one sublevel. Energy level 2 has two sublevels, the S and the P. The first one has one S. Third energy level has three sublevels, S, P, and D. The fourth energy level has four sublevels, S, P, D, and F. So when we fill it, we go from lowest to highest, right? Remember, the second energy level has split into 2s and 2p. Then we're at the 3s. Then we're at the 3p. Then we're at the 4s, not the 3d, because the 3d is slightly higher in energy than the 4s. Even though the third energy level is lower in total energy of the 4 energy level, when they split up, there is some overlap between the two energy levels. Then you go to 4p, 5s. Now look, 4d, 5p, 6s. Then you're all the way over to this 4f, etc., right? So we only go up in increments of the lowest energy that we can. Now, there's a way that we fill these, right? As remember here, we have to determine the number of electrons in your element or ion. We place electrons one by one into the energy level, sublevel, lowest energy sublevel first with the filling rules mentioned, and we stop when all the electrons are used up. So we're going to start putting electrons in this energy level first, then we'll move up to here, these three next, this one, these three next, etc., etc. And we'll show you how to do that on the next page. Now, the energy diagram that I just showed you with the lines could also be written with boxes instead. So here's a representation of it with boxes. Here's my box for my 1s, my box for my 2s. I need 3 boxes for my 2p because I had 3 lines there. S, P. You can see a pattern here. All the S's only have 1 box. The P's have 3 boxes. And if you get to the D, they have 5 boxes. So represented by 1 line, another line, and then 3 lines, right? These are both the same. These are both the same. All these equal each other. This side will equal this as far as being able to write that. So you can use boxes or lines. Now, one more thing to remember is that each box or each line only allows 2 electrons. So we can only put 2 electrons max per box or line. And if you do write the box or the line, you have to make sure you label what the box is or the line is, right? So if you can do that, then you're all set. Let's see how these work in real life. Okay, so let's choose an element to try this out with. Let's choose carbon. Carbon has 6 electrons. So we need to put in 6 lines or arrows onto this diagram. So let's start with the first rule was we start with the lowest energy level. So that's this one here. We put one arrow. You can either put it up or down, but the next arrow you put in has to be the other way. So I usually just start with all up. First arrow is up, so that means before I can move up, I have to fill this orbital. That's two arrows. Now I can move up to my next energy level, which is right here. And we're going to put one electron in there. So we still have 3 more to go, so a down arrow. And now my last 2 arrows, the second rule is Hund's rule, is that they go in as singlets before they start doubling up, right? So singlets, and when you're done, you count them. 2, 4, 5, 6. 6 electrons, so that would be it. So if you were asked to draw a diagram like this for carbon, 1, 2, right, ready to go there. All right, let's look at our next one. That's phosphorus. Phosphorus has an atomic number of 15, so it has 15 electrons. So let's start putting them in lowest to highest, right? So my first electron is going to go here, and I need one more to double it up. Now I have 13 left, and I have to put the next one here before I move up to the P. So I have how many left? I have 9 left. So there's 1, 2, 3. Remember, we fill these singlet first before we do go double them up. And there's 10, 11, 12. Now I can move to my P. 13, 14, 15. So that would be the correct configuration for phosphorus using the orbital diagram. Okay, instead of trying to remember which energy level, sublevel comes first and what's the order again, your periodic table is set up to help you do that very easily. Let's see how it works. In my first energy level on the periodic table, right here, I only have one sublevel, and that's the S sublevel. And there's only allowed 2 electrons in that, so we have element 1 and element 2, hydrogen and helium. Then I move down to my second energy level, and I have 2 sublevels in there, the S sublevel and the P sublevel. The S sublevel can hold a maximum of 2 electrons. The P sublevel can hold a maximum of 6 electrons. Then the next energy level, I'm in S. S, 3S, 3P, and 3D. Now, remember that the 4S fills before the 3D, and then you're back to the 4P. As far as energy, that's it, as far as energy. So, 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P, just like that energy diagram I showed you before. 5S, then you're in the 4D, then 5P, etc., right? So your periodic table tells you which orbitals fill in what order. Now, instead of using a very tedious and large occupying space orbital like the one we just showed you, with all these energy levels and which way they're filling, up and down and all this stuff, we need to transcribe it into something a little bit more manageable as far as saving space on a piece of paper. So, in order to do that, we're going to translate the ascending lines for the energy sublevels into straight line as follows. We're going to read it from left to right, and increasing energy goes from left to right. So for my first energy level, we have 1S. Then my second energy level has 2 sublevels, the S and the P, but the S is slightly lower in energy than the P. So we put the S first, then the P. Now we have to write one box or one line, another box, another line, something like that. 3 boxes or 3 lines. 1S, 2S, all these boxes represent the 2P. Then we have the 3S, then the 3P. Just as we're going here, 1S, 1S, 2S, 2S, 2P, 2P, 3S, 3P, 4S, etc., etc. So you're going to read it from left to right, left being the lowest energy, right being the highest energy. When you get to a block where you have all 3, like the P, they're all equal in energy. But you have to make sure you understand and denote it something like this, or a bar, or something like that underneath. So this is what it would look like if you were used to boxes versus the lines. So both are equivalent, both are accurate, and both can be used without having a penalty for one or the other. So let's look at how they would fill for each one. So remember, phosphorus had 3 unpaired electrons in the 3p, and everything underneath that was filled. So let's just quickly fill them in. So we have 1 arrow up, 1 arrow down, 1 arrow up, 1 arrow down. Then we fill this, this way. And then we get to the 3s, and then the 3p. And if you were to do it the same way for the arrows, you could just see it's the same way, except now instead of putting them in the box, you're going to just put them up and down arrows. And as you can see, everything looks the same except you don't have a box around the arrows on the lined ones. And you could do the same thing, so this would be for phosphorus. You could do the same thing for carbon. Carbon, remember, had 6 electrons, so we would fill it this way. And then if you do the lines, it would be equivalent. So both are correct, both are accurate, you can use either one, and this would be for carbon. Now there is one thing you need to do though. You need to make sure that you do label what each line is, right? So, or the box. So there's the 1s box, the 2s box. All 3 of these boxes are the 2p. And some people just write it this way. They put 3 boxes, and then in the middle box they put 2p. And it's assumed that these are all 3 boxes are 2p. Now some people just write, when they do it that way, they'll write 2p and they'll put a line underneath it to indicate 2p, or even some people will write 2p here and 2p here. But as long as the person reading this will understand that all 3 of these boxes here are 2p, and then all 3 of these boxes here are 3p, then you don't need to write anything a lot more than that, right? It just assumes that the reader knows that there are 3 orbitals in the 3p, and if you got to 3d, there would be 5 boxes or 5 lines, right? So either one of these is correct, but you got to remember to make sure that you label which box or line the orbital belongs to. Okay, so at this part of the video, you're going to stop the video, write all these elements down, and then write the correct orbital diagram for each element. So the goal here is to make sure you understand how to do this. So the first thing you're going to do is stop the video, write the elements down, look up the elements on the periodic table to see how many electrons they have, and then go from there. So when you're ready, stop the video, and then start the video when you want the answers. So stop the video now. Okay, so you should have gotten these answers. You can look them up really quickly. Hopefully you can read my arrows. But the bottom line is here. There should be 7 arrows for nitrogen. Fluorine should have 9. 12 for magnesium. 27 for cobalt. And 15 for phosphorus. And then carefully look at, you make sure you have these all labeled correctly. The 2p for nitrogen should only have 3 single arrows. Right? Everything here except for 1 single arrow for fluorine. Everything should be paired up for magnesium all the way up to 3s. The 3d on the cobalt should be filling after the 4s, and you should have 3 unpaired electrons there, and 5 lines, and again 3p for phosphorus. So check those to make sure that you understand and got them correctly. If not, go back and review the video. or come and find me. So there's an even easier way to write this than the arrows up and down the boxes. So this is going to be called the shorthand way, and this is the conventional way that most scientists will write electron configurations. Now, why didn't I teach you this before is because you have to visually see the arrows up and down the electrons before you can get into the shortcut. So that's why we did it this way. So if you look at this real quick, closely, you have this is your correct configuration for nitrogen. And this configuration becomes 1s2, 2s2, 2p3. So let's see how that works out. In my first sublevel orbital for 1, I have 2 electrons. So it's 1s2. And so we write it this way. 1s looks like it's a squared, but it's actually read as 2. In my second energy level suborbital s, we have 2 electrons. So we write that 2s2. In my second energy level p sublevel, I have 3 electrons in the orbitals, so I write 2p3. And then vice versa, you can see all the way down here for the other ones. Now, how does this work out to be? The first number here represents the energy level. And that will change depending on what energy level those electrons are in. So it'll be 1, 2, 3, 4, 5, 6, 7. But it tells you the energy level. The next thing here, the S, will tell you the sublevel. Okay. Now remember, each energy level has a different number of sublevels. The first energy level has 1. The second energy level has 2 sublevels, the S and the P. The third energy level has 3 sublevels, the S, P, and D, etc., etc. And then the last number here, this subscript, will tell you the number of electrons in that sublevel. So let's go through this again. I'm in the second energy level. I'm in this S sublevel, and I have 2 electrons in that. Let's look at magnesium down here. In my first energy level, I have the sublevel of S. I have 2 electrons. Second energy level, 2 electrons in the S sublevel. Also 6 electrons in the P sublevel for the second energy level. And finally, 3 energy level, S sublevel, 2 electrons. So pretty much that's how it's written, right? So it tells you all the information you need to know. Energy level, sublevel, and number of electrons in that. You don't have to worry about being paired or unpaired at this point. It's a quick way of doing it. And it fills the same way as before. 1s, 2s, 2p, 3s, 3p, 4s, 3d, etc., etc. Okay, so now you're going to try it on your own to see if you get it. And here's how you do this. You're going to first write down the element once you stop the video. And then you can either do it 2 ways. You can convert your arrow method into the shorthand, or if you think you're confident enough to do it by the shorthand, just by the way the electrons fill in the according to the periodic table, you can just go directly into the shorthand. All right. So whatever way you feel most comfortable with, stop the video, write all the elements down, finish the exercise, and then start the video for the answer. So stop the video now. So you should have gotten these answers if you had done them correctly. So let's just quickly review 1 or 2 of these. So oxygen. How many electrons does oxygen have? Oxygen has 8 electrons, right? And if you did the filling order correctly, there are 2 in the first energy level, S subshell, 2 in the second energy level, S subshell, and 4 in the second energy level, P subshell, right? And then if you notice here, when you add up all these numbers here, they equal 8. So if you add these numbers here, they equal 8. And that tells you that you did it correctly. Bromine is the same way, right? If you look at where bromine is, it's in the third energy level, and it has electrons in both the S and the P orbital, S and P sublevels, I'm sorry. And so everything else below that is filled. So this is filled, this is filled, this is filled. Even this is filled, and we're missing 1 electron in the P orbital, P sublevel. And so you would write it that way. And if you add them up, 2, 2, 6, 2, and 5, that equals 17, and you get the correct number of electrons. So if you don't get this, go back and try to review some more. But from now on, you should be able to write this no problem using any of the methods you have learned here today. If you still have questions, you can come find me and I can review with you.